The next part starts by examining the variable declarations. The program declares three integer variables: option, symbol, and die. The symbol variable is an array of size 100, which means it can hold up to 100 integer values. The I variable is initialized to 0. Next, we see three float variables, num1, num2, and results. These variables will be used to store the operands and the result of the arithmetic operations performed by the program. Finally, we see that the program declares a two-dimensional float array called computation. This array has 100 rows and 3 columns, which means it can hold up to 100 sets of operands and results. Now that we have looked at the variable declarations, let's move on to the rest of the program. Here we see two variables declared, again and input. The again variable is a character and will be used to determine whether the user wants to compute again. The input variable is a character array of the size 100 and will be used to store user input. The next part of the code, we have a do-while loop that displays a menu of options and then validates the user's input to make sure it is a valid choice. Let's take a closer look. First, the program displays a menu of options using the printf function. The options are add, subtract, multiply, divide, and exit. Next, the program enters a do-while loop that will continue to run as long as the user enters an invalid option. The loop contains an input validation function that uses the fgets, sscanf functions to read in the user's input and check that it is a valid integer between 1 and 5. Firstly, fgets input 100 stdin is used to read input from the user. It takes three arguments. Input is the character array where the input is stored. 100 is the maximum number of characters to read. And stdin specifies that the input is coming from the standard input stream, which is typically the keyboard in this case. Now let's move on to the input validation loop. The purpose of this loop is to ensure that the user enters a valid menu option, which should be a number between 1 and 5. This is important because if the user enters an invalid option, the program might not work as expected. The loop starts by displaying a prompt to the user asking them to enter their choice. It then uses fgets to read the input from the user and stores it in the input character array. The loop then uses sscanf to convert the input from a string to an integer and store it in the option variable. The loop then checks whether the conversion was successful and whether the value of option is between 1 and 5. It also calls the isInvalidInput function, which is likely a custom function to check for any invalid characters in the input. If any of these conditions are true, the loop will continue to prompt to enter a valid option and displays an error message saying invalid choice. If the user enters an invalid option, the program will display an error message and ask the user to enter their choice again. This do-while loop will continue to run until the user enters a valid option. Once the user enters a valid option, the program will move on to the next section of the code, which performs the requested arithmetic operations. If gets input, 100, stdin is used to read input from the user, while the input validation loop ensures that the user enters a valid menu option. By using these techniques, the program can handle user input more robustly and avoid crashes or unexpected behavior. The next code is a part of the larger program that allows the user to perform various arithmetic operations. After validating the user input for the menu option, the program checks if the user wants to exit the program. If the user selects the exit option, the program will check if any arithmetic operation has been performed. If no If no operation has been performed, the program will terminate without performing any operations. Otherwise, the program will exit the loop using the break statement. The next two do-while loops are used to validate the user input for the first number and the second number. These loops have similar structure to the first one, but they use the sscanf function to convert the user input to float and store it in num1 and num2 variables respectively. The isInvalid function is used to check whether the input is invalid or not. So these loops ensure that the user inputs valid values for the menu option, first number and the second number. After validating the user's input, we perform the arithmetic operation and store the result in a variable called result. The perform operation function takes in the operator and two numbers and returns the result of the arithmetic operation. Next, the program displays the result of the operation. If the user attempts to divide by 0, the program displays undefined instead. After the arithmetic operation is performed, the result is displayed. The code stores the computation history in a two-dimensional array called computation. It stores the first number, second number, and the result in the array, along with the arithmetic operation symbol. Then the code prompts the user to compute again by asking whether they want to continue or exit. The input is validated in a loop similar to the previous input validation loops. The entire process of accepting input, performing the arithmetic operation, displaying the result, storing the computation history, and prompting the user to compute again continues until the user enters n, or n when prompted to compute again. The next code begins with a comment that indicates the level to exit the program is being defined. This label may be used to jump out of the program's execution from anywhere in the program. The if statement checks whether option is not equal to 5 or I is not equal to 0. If either of these conditions is true, the following message is printed to the console. After printing the termination message, a for loop is used to iterate through a two-dimensional array called computation. The loop starts at 0 and iterates until j is less than I. During each iteration of the loop, the following code is executed. This printf function prints the index number j plus 1 and the first element of the jth in the computation array. The .2f format specifier ensures that only two decimal places are printed. This code uses a switch statement to print the appropriate arithmetic symbol based on the jth element of the symbol array. The possible cases are 1 for addition, 2 for subtraction, 3 for multiplication, and 4 for division. This code prints the second element of the jth row in the computation array and an equal sign. While this code checks if the third element of the jth row in the computation array is infinite. If it is, the string undefined is printed to the console. Else, if the third element of the jth row in the computation array is not infinite, it prints the number with two decimal places to the console. Finally, the code returns 0, indicating that the program has executed successfully.